Okay, so everyone, let's start the class. Okay, so now basically in this, this is the last topic of this chapter that is called conservation of momentum. So in this topic, we are going to study what will happen if two bodies collide. Okay, what are the, you can say, consequences of that collisions, and what is the, you can say, equation involved in it, and what is the law involved in it. Okay, so basically conservation of momentum means simply you must have understood that conservation, like you must have heard this thing like conservation of mass, conservation of energy. They says that, and if we talk about conservation of energy, this says energy neither be created nor be destroyed, but it can be transferred from one form to another, right? So this is the case in the in conservation of energy, everyone. Yes or no?
Yes,
Okay.
sir.
Yeah. So yeah.
Yes,
So
sir.
basically the laws which involves the word conservation, it means that simply it can neither be created nor be destroyed, but that quantity can be transformed into another one, right? So right now, suppose that, let me take a picture of that. Okay. So let me take a picture. This is a very simple example that we basically have seen like in the movies or in the real world as well. Just let me. So suppose that, everyone, so this is a scenario, okay, that you have to understand here. So suppose that, everyone, that this is a truck and this is a car. So in this starting, if we talk about initial case, or you can say initial scenario in that, so basically truck was moving with some velocity. Suppose that, and the car was also moving with some velocity, initial velocity u2. U1 is the initial velocity of the truck and u2 is the initial velocity of the car, right? So this was the momentum of the truck, this was the momentum of the car, because every body will, you can say, have its own momentum. Yes or no, everyone? Yeah.
Yes, sir.
So but
Yes, sir.
due to basically, but after some time that there is a collision happened between the car and the truck. So as you can see this thing, the car, basically the truck struck the car from basically from behind. Okay, and due to that, the velocity of both truck and car has been changed. Can you tell me what you can say, which will move forward, which will move faster and which will be which will become slower after the collision? Anyone? Now, which will have more velocity, or you can say which will gain some
So
velocity?
the car,
The car, the car. Faisad, okay. Anam, Sara, Hanan, Samya,
Sir, the car.
the car. Okay. Anyone else? Hanan, Samya, oh sorry, Sara and Anam.
The car. The car.
Yeah. Yes, car. So, in simple words, if you talk about, suddenly if you're standing still, and suddenly a person basically comes from backward and basically make a push to yours, to you, what will happen? You will go in the forward direction, right? You will gain some velocity, right? So in this case as well, the basically the truck basically struck the car from the backward direction, and so that's why the car will gain some velocity. It will gain some velocity and it will lose some velocity. You must have seen that after the collision, so basically one object will gain more velocity and one will lose it, right? So in this case, truck is going to lose and car is going to gain. It means that there is a change in momentum. Yes or no, everyone?
Yes, sir.
Because
yes, sir.
velocity has changed. Mass is going to remain same, but only thing that can be changed is the velocity. So velocity is going to change, and that's what leads to the change in momentum. So it's only says that if the truck has some velocity, you can say m1 and u1 is the mass and initial velocity, m2 and u2 is the mass of the car. Okay, so if you basically compare collision, so total momentum before collision and total momentum after collision would be same. It is not going to change. Only it will transfer from one body to another body. Okay. Truck has some, suppose in that case, truck has some more momentum, but after the collision, the car has gained some more momentum than the truck, and it has lost some momentum. Clear? Sara, Samya, Hanan, Anam, and
Yes. Yes,
Sad.
sir.
Clear,
Yes, sir.
everyone? Chalo, ठीक है. So that's what the conservation of momentum is. Clear? Sure, that's good. So let me write it down. Let me write down the statement. Okay. So it says that when two or more bodies act upon one another, their total momentum remains constant or conserved. Or in terms, or you can say constant. Okay. Clear, everyone? Provided no external force. So there should not be any external force. External force are acting. Okay. So forces should not, any external force should not be acting on them. Okay. Clear, everyone? Please let me know once. Is there anyone to which to whom it's not clear?
No, sir.
Chalo, check it. Check. Okay. So this is what the conservation of energy. Sorry, it's not energy, momentum. Okay. So if you talk about the conservation of, okay, let me write down the the formula. That is nothing but this one. So if so m1 u1 plus m2 u2 will be equals to the final momentum, that is m1 v1 plus m2 v2. Okay. So this is what the conservation of momentum. So momentum can neither be created nor be destroyed, but it can be changed to another form. Okay. Okay. So basically, if we talk about the momentum applications, the conservation of momentum applications. So basically, we have seen this thing in the you can say the when we fire a bullet from a gun, so conservation of momentum is applied. Okay. And if we talk about the space jets, that we have seen that rocket will go in the upward direction. Okay. So conservation of momentum is applied in that case, and the aeroplane. Okay. So these are the conservation of momentums. You can say applications. Okay. So first of all, let's analyze this thing first one, and then we will do the numericals based on that. Okay. Actually, everyone, I just wanted to ask. चलो ठीक है कोई बात नहीं right no worries. So applications of conservation applications of conservation. The first we can talk about the you can say we have basically the working of you can say rockets, aeroplanes, and space jets, or you can say rockets. Okay. Rockets and jet planes. Principle of conservation of momentum ठीक है. So let me tell you how it is possible. Like, so in jet planes or in the rockets, okay, in jet planes, a large volume of gases reduced by the combustion of fuel. So, so the basically is allowed to escape through a jet in the backward position. So basically, you can say the exit point for the gases that is basically burning inside the fuel tank, okay, or engine. So basically, there is a very small, you can say exit, and basically the gases comes out with a very, you can say high speed in the backward direction. So basically, this produces a moment. This produces a force. We can say a movement in the forward direction, right? So basically, initial momentum is equals to the final momentum. Okay, through a jet in the chicken. So this imparts a high speed or velocity backward rushing gases have a large moment. Okay. So this imparts the same momentum in the forward direction. They impart an opposite momentum to the jet. Okay. So that's what. Okay. Due to which the jet moves forward with a great speed. Okay. So this is Clear, everyone? Please let me know.
Yes, sir.
Anyone else?
Yes, sir.
ठीक है? चलो, so if let's
Yes,
talk the
sir.
second. ठीक है, so let's talk about the second case. जल्दी से फिर उसके numericals कर लेते हैं. So basically, firing of a bullet is also based on the conservation of momentum. ठीक है? Firing conservation of. So so basically, when a bullet is fired, so basically, I've told you in the last, I think, say I was maybe, in the third law of motion, I've told you about that. When the bullet is fired, so there is a backward force as well. There is a jerk in the backward direction to the shoulder. Do you remember, Bachu? Yes or no?
Yes,
Do you
sir.
remember this thing? Yeah. So basically, that jerk is to basically, you can say, follow this conservation of law. So, conservation law of momentum. Okay. So, let me write down here. When from a gun, then the bullet has the moment as mass of the bullet into velocity. So this is the, you can say, so the bullet imparts an equal force in the backward direction and opposite momentum. To the gun. Okay. Due to which the gun moves in the backward direction. Jerks backward. Yeah. This is said to be recoil. So this property of the gun is called recoil. And the backward velocity of the gun is called recoil velocity. Recoil velocity. Okay. So the momentum acquired by the gun would be mass of the gun and recoil velocity of the gun. Okay, so recoil velocity is the velocity with which the gun will jerks backward. Okay, clear everyone?
Yes, sir.
So according to the law of conservation, conservation of momentum. Okay, according to the law of conservation of momentum, momentum of bullet is equals to momentum of gun. Okay, we talk about that. So momentum of bullet is equals to momentum of gun. Okay. And if you write down the things in terms of mass and velocity, mass bullet into speed bullet will be equals to mass of gun into recoil velocity. Okay, everyone, please let me know if this is clear to you or not.
Yes, sir.
Okay, so this is how, so these are the applications of the conservation law of conservation of momentum. Okay, so basically these two are the, you can say, the popular and the common one that can be there in your school exams, like what is the working principle of a jet airplane or rocket, and what is the work, like explain the, you can say, the recoil of a gun in terms of law of conservation momentum. So that's how you have to explain it. Clear, everyone? Is there anyone? Please let me know. Is this clear to all of you?
Yes, sir.
Chalo, that's great. Okay.
Yes,
Okay,
sir.
now let's do a numerical based on that. Okay. So how to solve the like numerical based on the conservation. So question is saying a bullet of mass 10 gram is fired from a gun of 6 kg. Calculate, and the velocity of bullet is 300 meter per second. So we have to calculate the recoil velocity of the gun. Okay, so simply let's our first task is to write down all the given things that is given in the question. Clear, everyone? All the given values given in the question, right? Okay, so mass of bullet is, so mass of bullet, I'm going to denote it with small m, that is 10 grams. Okay, now I'm going to convert it into kgs. So 10 into multiplied by 10 to the power minus 3. Is this clear? Is this step clear? How to convert gram into kg, everyone?
Yes, sir.
Okay? Because nothing but it's, I have divided it by 1000. So if I take it in the numerator, that would become 10 to the power minus 3. Right, everyone? So that will become 10, negatively 10 to the power minus 2 kg, right? And mass of bullet gun is already in kg. I'm going to denote it with, not gum, it's gun. Just a second. I'm going to denote it with capital M. That is 6 kg, right? And velocity of the bullet is given to you. So it is, velocity of bullet is a small v, because bullet is a small object or a small body. So I'm going to take all the things in small for the bullet. V is equals to 300 meter per second. It's already in SI unit. So we have to find the recoil velocity of gun, right? So recoil V, that we have to find. Okay. So momentum of, first of all, what we will find out? We will find out the momentum of a bullet and momentum of the gun. Okay. So let's write it down here. So how can you write it? Momentum of bullet will be equal to the momentum of gun. Yes or no, everyone?
Yes, sir.
Okay. So momentum of bullet is mv is equals to mass into velocity. Okay. So I'm going to substitute all the values given in the question. So mass is 10 to the power minus 2 into 300 is equals to, mass is 6 into v. Okay. So v will be equals to, देखो, 10 to the power minus 2 is nothing but 1 by 100. Okay, now, ठीक है, 1 by 100, ठीक है, and so it will cancel these two 100, so it is going to be 3 divided by 6 meter per second, ठीक है, so that is coming out to be 0.5 meter per second, and you are right here, ठीक है, so is this clear, all of you?
So is it okay if I convert 6 kg into 6,000 grams and then do it?
Convert.
So I converted 6 kg into 6,000 grams and then I
Yes,
saw.
that, okay, no issues, because what will happen is that if you convert it, because kilogram, basically mass is going to cancel out, because we need to find the velocity. Okay, so mass will get cancelled out if you change it, so that's not going to affect your answer. Okay, that is also fine, no worries. Okay, is this clear to all of you? Samya, Saad, Sara, Anand, and Anam?
Yes, sir.
Please let me know, everyone. Is there anyone who has doubt? Okay, sure, that's great. Okay, now let's do one more question. Okay, so I'm giving one question just for at least try. Okay, just at least try. Implement the law of conservation of momentum. Okay, let me give you the picture as well of this question. Please do it, everyone. Any answer from anyone? Please let me know in the chat. I got the first answer by Samia. ठीक है Samia. Okay, Saad, no worries. I will explain. No need to worry. Any answer from anyone? I got no answer. Okay, Sara, no worries. ठीक है, कोई बात नहीं. Okay, Anand. ठीक है. Anand, you also gave me the answer. Okay, ठीक है. Okay, okay, let's do it together. ठीक है. Let's verify it. So question, let's analyze the questions one by one. Question is saying the car of mass A is 1500 kg and traveling at a speed of 25 meter per second. It collides with a car of 1000 kg and the velocity of the car is 15 meter per second in the same direction. Okay. It means that after, okay, so before this was the situation before the collision, right, everyone? After the collision, the velocity of car A becomes 20 meter per second. So they go. Now you can see that velocity of car A has decreased by the collision, right? Calculate the car velocity of car B after the collision. Okay. So a simple formula. The first formula that you have to think about this kind of question is that total momentum will be equals to the final momentum. Is this clear to all of you? Please let me know. ठीक है. So
Yes,
जल्दी
sir.
से हम लोग इसको इसको हम लोग show करते हैं. M, I'm taking M1, that is M1, and I'm taking in terms of M1 M2 because MA if I write it in subscript that would be very like not clear. ठीक है. So M1 will be equals to 1500 kg. V1 is equals to इसको U1 कर लेते हैं. U1, let's take it U1. ठीक है. U1 is 25 meter per second. ठीक है. And M2 is equals to 1000 kg and U2 कितना है 20 है ना शायद से 15 है 15 है सॉरी 15 meter per second. ठीक है. And the final velocity after the collision is 20 meter per second and V2 is कितना है 10 like we have to find. ठीक है. So देखो what we will do is that we will find out the momentum, total momentum before collision. ठीक है. Will be equals to P1 plus P2, everyone, yes or no? So this is going to be P1 is M1 U1 plus M2 U2. Write down the values or substitute the values in it. So 1500 into 25 plus 1000 into 15. Okay. So this is going to be these values. Plus 15 kg meter per second. So total it would be 52,500 kg meter per second. So this is the total momentum before collision. Is this clear to all of you? So total momentum after collision we have to find. Again P1 plus P2, check it, is equals to M1 V1 plus M2 V2. Okay. If you write down the things will be equals to M1 is 1500 into 20 plus 1000 into V2. Okay. So this is going to be plus 1000 V2. So this is the momentum and the value would be kg meter per second. Okay. So this is the momentum after the collision. So now what we do is that we will equate both the momentum because according to law of conservation, the momentum before collision and the momentum after collision would be same. Okay, so I'm writing here. According to law of conservation of momentum after collision. Okay. So initial momentum was 52,500 will be equals to 30,000 plus 1,000 V2. Okay. So I'm going to take 30,000 on the left hand side. Okay. So 1,000 V2 will be equals to minus 30,000. Okay. So V2 will be equals to 52,000 minus 30,000 would be 22,500. So V2 will be equals to 22,500 by 1,000. Okay. So two zeros will get cancelled and 1 zero will make it a decimal. So 22.5 meter per second. The velocity of the car B is going to be 22.5 meter per second after the collision. Is everyone, is this clear? Let me know. Is this clear?
Yes, sir.
All of you?
Yes.
Anyone, any doubt so far? Saad, Hanan, Sara, Anam,
No,
and
sir.
Samir.
No,
Okay?
sir.
Sure, that's great. Okay, so basically right now, like we have only 5 minutes, so like the questions related to this won't be able to that. I just wanted to ask one thing. So basically, as you know, this chapter is going to end in the next class. Like I will, like 2 or 3 numericals will be there, all like also in the start of the class. So after that, which chapter you would like to start? I was thinking this chapter. Let me tell you why. Because this chapter is really basically like concepts and used in this chapter is basically a force. So basically, so if you do this chapter, that will be much easier for you. If you do gravitation, so you have to revise and all the things. So that will be a little bit tough after the gravitation chapter if you take this chapter after gravitation. So I just wanted to know which chapter you would like to start, because these three chapters, work energy, force, and motion, are interrelated to each other. Bolo, everyone?
So I think gravitation is coming in my half-yearly exams.
So gravitation. Chalo, ठीक है.
Yes,
Anyone
sir.
else? Sads? Which one? Samir?
Sir, gravitation.
अच्छा, आपके भी एग्जाम में ये आ रहा है सामिर?
Yes, sir.
चलो ठीक है. सात? सात है ना?
Sir, in my half-yearly exam, work and energy chapter is coming.
वर्क. ठीक है. ठीक है साद. ओके, यू कैन चेक एंड एटलीस्ट देखो, फोर्स एंड मोशन तो आपके 2 चैप्टर तो कंफर्म है. ओके, सो 2 चैप्टर्स आर कंफर्म फॉर योर मिड टर्म. Okay, so and those 2 chapters are end. Okay, are completed. So the third chapter is like some are like some people are having work energy and some people are having gravitation. So देखो फिर उसके बाद तो अभी क्योंकि अभी तो देखो आप only 4 or 5 students are there right now. once other 6 students, I have to ask from them. So whatever their responses are there, okay. So we have to conclude that responses, and according to that, I think like majority, whatever the majority says, we'll take that. And for those who are having like gravitation, suppose that work energy is basically started in the batch class. So I will do one thing. I will take gravitation extra classes and complete that for those that for those students in which their half yearly the gravitation chapter is coming. Okay. And if I start the gravitation and work energy is coming in other student, like in the midterm of the other student, so I will do the same for the work energy. Is this clear, all of you?
Yes, sir.
Yes, sir.
Okay, like some students have gravitation, some have work energy and power. So there is a clash. So whatever the majority will say, I will start that chapter. And तो like suppose अगर मैंने gravitation start किया, तो work energy जो भी students होंगे उनके लिए मैं extra classes arrange करके उसको backup मिल जाएगा, ठीक है. एंड अगर वर्क एनर्जी स्टार्ट की, सो ग्रेविटेशन के लिए 2 और 3 स्टूडेंट्स जो भी होंगे, बिकॉज तेजस इज ऑल्सो अ स्टूडेंट, अनम है, एंड शायद से अरहान, सो उनकी भी ग्रेविटेशन आ रहा है. सो 3 स्टूडेंट्स हो जाएंगे, तो मैं उनको एक बैकअप क्लास दे दूंगा ग्रेविटेशन चैप्टर की. सो क्योंकि देखो आपको एग्जाम के लिए तो करना ही है प्रिपेयर. सो चाहे आप वर्क एनर्जी बाहर पहले कर लो या फिर ग्रेविटेशन पहले कर लो, तो जो भी जिसके अकॉर्डिंगली आ रहा होगा, तो वो दोनों चैप्टर साइमल्टेनियसली चलेंगे, ठीक है. क्लियर?
Yes, sir.
ओके साथ, फिर भी लाइक डू यू हैव एनी कांटेक्ट विद योर टीचर, साथ school teacher or something like to reception, or you can get her number or his number. अच्छा ठीक है. तो साथ please message your teacher and ask him or her to tell at least which chapter is coming, so that you can prepare for that. If suppose that force and laws of motion are coming, so that is well and good. If suppose third chapter, at least you need to know whatever the chapter is, because you have 5 chapters. So in my opinion, so 3 chapter will be coming in your midterms. ठीक है. So साथ please ask from your teacher about the same and let me. Okay everyone. बस एक टॉपिक आपका मुझे अलग से मतलब एक ग्राफ लाइक डेरिवेशन वाला पोर्शन नहीं हुआ है अभी तक. सो बेसिकली है ना, वंस ऑल स्टूडेंट विल ज्वाइन, क्योंकि देखो 2-3 स्टूडेंट्स और हैं, तो उनके साथ आपके लिए मैं एक क्लास अलग से शेड्यूल कर दूंगा. डेरिवेशन पोर्शन जो हमारा रह गया था ग्राफिकल अलजेब्राइक वाला, ठीक है. सो वो वाला पोर्शन हम लोग वहाँ पे कवर कर लेंगे, क्योंकि अभी 2 और 3 स्टूडेंट्स हैं जिनके भी ये पोर्शन आ रहा है, ठीक है ना. इज दिस क्लियर?
Yes, sir.
ठीक है. चलो. सो मैं अभी जैसे कि मतलब एक फॉर्म लाइक सेंड कर दूंगा बच्चों को. सो गूगल फॉर्म, सो उसमें आप अपने रिस्पॉन्डेड रिस्पॉन्स फिल कर दिएगा कि उसमें कौन सा चैप्टर आप स्टार्ट करना चाहते हो, तो वो मेजॉरिटी केसेस में उस चीज को हम लोग हैंडल कर लेंगे, ठीक है.
Sir, I
Clear?
wanted to ask that
हाँ.
can you schedule the class for the algebraic representation earlier than 12th, because I have a physics test on 12th and all of the representations are coming.
Earlier than 12th of August.
Yes, sir.
ठीक है. Okay, I will schedule. No need to worry. Okay, no need to worry, because graphical portion we have already done. Only the topic left is algebraic one, so we will take it. No need to worry, ठीक है.
Okay, sir.
अच्छा सारा एंड अनम, अभी आपका जो पोर्शन रह गया था वो एवरेज वेलोसिटी वाला, जो हम लोग नहीं कर पाए थे. अगर इफ आई गिव यू रिकॉर्डिंग्स एंड उसके बाद हम लोग डाउट क्लासेस शेड्यूल कर लें, क्योंकि थ्योरी पोर्शन रह गया था, तो इज इट फाइन और यू वुड लाइक टू टेक अ बैकअप फॉर द कंप्लीट थ्योरी क्लास, सारा एंड अनम?
So I think recordings would be fine for me.
ओके ठीक है अनम. सारा, व्हाट अबाउट यू?
Sir, same recording will be fine.
चलो ठीक है, कोई बात नहीं. सो आई विल शेयर द रिकॉर्डिंग, ठीक है, टू बोथ ऑफ यू. And if like Samia, Hanan, do you have any doubt in the average velocity or any other topics? So I will.
No, sir.
चलो ठीक. Hanan?
No, sir.
चलो ठीक है. Okay, Sarah and Anam, I will share the recordings. If you have any doubt, you can reach out to me anytime. Okay.
Okay, sir.
Sure, that's great. So this is all about this class. Thank you so much for joining the class and giving me your time. Okay, so there is no assessment after this class. Just go and enjoy. And I will share some assignment questions to all of you for based on the conservation of momentum. Okay. So in the next class, this topic will be done. 2 or 3 types of numericals are still left. And once we will do this, do those questions or numericals.